Good morning, Chris here, Griffiths Heating. This is our latest job, which is a air source heat pump install. This property is a 2-bedroom, 1-bath bungalow, direct electric heating, so storage heaters in every room, a 4-tick tank in the attic, and we're upgrading it to an 8 kilowatt Viessmann air source heat pump. Seeing it's a direct electric heating system, it's eligible for the £5,000 bus grant. So a lot of people say air source heat pumps are expensive to install and they don't work, etc, etc. So in the comments, how much do you think this install is costing this customer with the grant applied, and how much different would it be from, say, we're putting a gas combination boiler in? Obviously a high quality system, correctly designed to low flow temperatures. Yeah, answers in the comments, and at the end of the video we'll give you some numbers and show you that it's how expensive it is to retrofit or do a first fit on a heating system that's a property that's never had a heating system, to do an air source heat pump from the get-go. This is the range of pipe we'll be using on this job. We've got our 32mm main circs for the heat pump up to the controls in the attic, and then we've got a 25mm MLCP, which will be the main carcass of the heating system, and each rad will be piped up 16mm. So everything's in MLCP, composite metal layered pipe, you might not really see there, outer layer, metal layer, and the grey smooth layer in there. So 32mm for the main circs, for the heat pump, 25mm for the heating system, main circs, and 16 to each rad, as you can see there. So we're going direct into each radiator with MLCP with a little adapter. I'm trying to not solder on this system, do it all in press or MLCP, just to get any flux out of the system and prevent the system becoming acidic or upsetting the water quality, leading to corrosion in the radiators, leading to a blockage in the plate heat exchanger on the air source heat pump. So we're on day 3 of the install. We've got the circs dropped down to the heat pump. Heat pump's there, sitting on the anti-vibe rubber feet. Flexible hoses off the unit into some anti-freeze valves. Sparky's in the process of doing the sparking, so they will be clipped neat once it's finished, and everything will be lagged. Valves, strainer, and I think that's all there is to say about it really. Control wise, we've got on the control section, on the 100A you've got a cable for the 3-way diverter, a cable for the relay that operates the on-off controls for the thermostat, and a 2-core for the NTC off the hot water tank, and just a 2.5 for the power to the unit. So that bit's in progress, that's nearly done. So inside the property, all the radiators are done, everything's piped. Got a couple of verticals in the lounge, either side of the sofa, so it's quite a big lounge, so we need 2 big verticals for the output. And we'll shoot up into the attic and have a look up there in a minute. So here's the finished heat pump install. Turned out quite nice. I was a bit worried that it was going to look a bit messy, but we got it to work really good. So the way this one's set up, we got the primary flow off the heat pump here, 2-way diverter, normally open to heating, into a buffer, straight back down. We get 240 on the domestic, that swings over there, and we get through the coil, back down through the turn, through the spiromatic filter, back to the heat pump. Reason for the buffer is for defrost, not for hydraulic separation. If you've got TRVs on the system, it can't be considered open loop, so you can't count the volume of the water in the radiators in the defrost volume. So you can either have an inline buffer or a parallel. I prefer a parallel buffer. Some people may prefer an inline, so we went with a parallel buffer. Pipes come out that side, heating pump down below. We were going to put it up here, but because there's a bedroom below, we were concerned about vibration, so we stuck it in the coat cupboard. Wiring wise, there's a controller built into the side of the heat pump, so all we need to do is make and break the digital input on the heat pump with that relay fed through a hive, and the controller on the heat pump does the set point curves. It's pretty simple. Bit tricky to set up because the instructions aren't great, but we got there in the end. So yeah, 240 volts to the controls. The cool for heat opens the relay, which loops through the digital input, which then brings on the pump. Really quite simple. Not the greatest, most advanced control system, but it's got a set point weather compensation curve on it, so it should do the job. So we'll go downstairs and have a look at the heat pump now. So here's the heat pump currently whirring away. It's not as quiet as the 150As, but it's half the price of a 150A, so you paid your money, you take your chance. Control wise on the heat pump, this is your built-in controller. It's not the easiest bit of kit to set up. We had to ring technical to get it going. They talked us through the procedure because the information you need to set it up isn't in the handbook, all the service codes and access levels, and it doesn't tell you what parameters you need to change to get it going, so that was a bit tricky. Not too keen on this. The connections here, this box doesn't fit back on once the connections are made, so we had to modify the box and lag it the best we could. We've got some anti-freeze valves under there, and this shoots back over here to the waterproof lagging. Got all the joints taped, electrical isolator. There's a drain over there, you probably can't see. It catches the condensation off the evaporator and drains it away. And that's about it really. The main thing, like I said before, the main thing I noticed with this unit is it's nowhere near as quiet as a 150A. I don't know if you can hear that purring away now. I mean, it's not intrusive, but 150As are virtually silent in operation. But for the price, I don't think you can grumble.